All right, so we are continuing our work on exercise 3.21 on page 128. We are working with the output. We have our fixed cost, 1980. We have our slopes for each of our variables, x1, x2, x3, and we have already figured out the formula. We've applied the formula and come up with 5791 in overhead if we use 550 labor hours, 35 wedding cakes, and 20 gift baskets. We would have that much overhead. Of course, this is just an estimate, so how good of an estimate is it? How confident are we? Let's do a confidence interval. I wouldn't expect you to be able to calculate this, but just know some of the terms. So question number 3 asks us, calculate a 95% confidence interval for the prediction made in requirement 2. Round to the nearest dollar. All right. So in order to do this, we need a couple of things. We're going to need to use that table, which obviously I'm not going to have you do this in real life, but you may remember that let's see here. Where was that table? So there was a table for when you do a t-test, and you look up your degrees of, there it is. It's on page 314, and you look up your degrees of freedom and what confidence level do you want. In real life, you do this with computers and spreadsheets and things, but what we've got going on here is we want a 95% confidence level. And how many degrees of freedom do we have? Well, we need to figure that out. Degrees of freedom is based on number of variables, right? And observations. So if you look here, it tells us there's 24 observations. So that means we had like 24 months or 24 weeks or whatever this is, 24 years. We had 24 observations. All right, and how many variables? Well, we have our fixed, that's a variable, and labor, wedding, baskets. So 4. So 24 minus 4 is 20. That's degrees of freedom. All right, so we come over here to 95%. I'm sorry, let me get this in our frame. 20 degrees of freedom. 95% confidence level. So for our t-distribution, we need to use 2.086. All right, so there you go. We need that, and we need the standard error, which again is also coming from our output. All right, 65. All right, so 2.086 from the table and 65 for the standard error. So, confidence level is our total costs, so we'll call that Y, whatever we want, plus or minus our t value times the standard error. All right, so we got 5791, that's the number we calculated, right, plus or minus 2.086, that's the number we got with our 20 degrees of freedom, 95% confidence, times our standard error, which I got from the printout, 65. All right, so that means 5791, this should kind of look familiar, 57 from statistics class, plus plus or minus 136. So 5655 through 5927, we're 95% certain that this number falls within our, that we have predicted a number within that confidence level. All right, so 95%, that's pretty good. And finally, 4, what does R square mean? What does R square mean? Okay, so let's look at R square, 92.92, I'm sorry, 92%. So this is telling us that overall, this model is a good fit. We have it's pretty good, 92%. This model explains 92% of the variation in overhead costs, right? So that's pretty good. It's a good fit. We can be highly confident that we can predict our overhead. All right, so now that you know, you can work in your costs and figure out if you want to do extra gift baskets or extra wedding cakes or whatever, because you are able to predict your overhead, and that's important. All right, so that's all the problems I'm going to work for you. You should go practice your homework and go practice your quiz. And hey, this is chapter 3, so after you finish that, there will be an exam over chapters 1, 2, and 3. So get on that. Good luck.